Hello everyone. So let's see how to solve today's question. So today's question is lexicographical numbers. So the question is given an integer and written all the numbers in the range 1 to n, sorted in the lexicographical order. So what is lexicographical order? Let us first understand that. So if we take the example as suppose in English, how do we write the words in like lexicographical order? So they are written as A, then it would be AAB, or like these. Okay, so this is lexicographical ordering. Okay, so in the case of words we can clearly see what lexicographical ordering is, but how do we define lexicographical ordering in numbers? So in numbers also it is similar only. So if you take one, this would be the first like number which would be in lexicographical order. Then after this, like what would come first? Like so if you take natural ordering, the natural ordering is one, two, three, four, five, and all. Okay. So but that's not what we are talking about over here. So lexicographical ordering, after one, one zero will come. Okay. Because zero you can consider it like A. So this you can consider. Okay, so 0 is as A because after 1, the smallest number which I can append will be there, and only then my lexicographical order will be followed. And what will come after 1 0? So suppose if you take an example of like if you have to generate lexicographical number till 2000, okay, just in random number. So after 1 0, what will come is 1 0 0. Okay, because I can, because it is still is smaller than 2 0 0, so this will come after that. Okay, so what will come after 1 0 0? After 1 0 0, the number which will be there is 1 0 0 0. Okay, so that's how it will be. And suppose if after that also we need to generate, so we will go and check uh, like 10 0 0 0, like 10,000. So this will be not a valid one because we have to generate till 2000. So we just remove it from over here and we again go upwards. Okay, so now what will be the next number after it? Okay, so any guesses like what can be the next number? So the next number will be 1 0 0 1. Okay, so after that, what will be the next number? 1 0 0 2. Okay, so in this level, whatever like numbers I can make which are less than 2000, I will create them, and after that I will return. Okay, so once all this like 1000 numbers are generated, I can do it. After that, what will be the next numbers? So the next numbers will be 1 0 0. After that, there will be 1 0 1. Okay, then there will be a new. Then the next number will be like 1 0 1 0. Okay, after that, one more call can be there like 1 0 1 0 0. Okay, but as this will be greater than 2000, so we don't need to consider this. So after 1 0 1 0, the next number will be 1 0 1 1. After this also there can be a call, but I'm not making that because if we have append a zero after it, it will be outside our range. So what will be the next number after this? This will be 1 0 1 2. Okay, so these how this will be generated. So once we have generated all of these numbers, so similarly we will go on. We will take into 1 0 2, and then 1 0 2 0 will be there, 1 0 2 1 will be there, 1 0 2 2 will be there. Okay, so that's how the numbers will be generated. Okay, so I hope you are able to understand it. So let's just generate few more. So once suppose if all of these are also generated, like 1 0s are done, then what will happen is that then the next one will be 1 1 1. For double one, just the next lexicographical will be 1 1 1 0. Okay, so this will be 1 1 0. Okay, so after this we can make one more call which will give us 1 1 0 0. But as this is also in our range, so this will be there. After that, the next number will be 1 1 0 1. Okay, after that, well, it will be 1 1 0 2. Okay, so that's how this will be generated. So I hope you are able to get the picture. So that's how we get the numbers. Okay. So once these all are done, like 1 2 4, it will happen. So this will go on. This you can also like I think by now you must have think of a recursive way. Like this is some sort of recursive way in which we are generating. So we will see how to generate them in the code. But so if you go ahead and read the next line, you must write an algorithm that turns in O of n time and uses O of 1 extra space. So based on our initial dry run only, we can see like this seems like a recursive problem, because for each of the number, what I'm doing is I'm trying to generate all the next like lexicographical numbers afterwards. So suppose I have taken one for now, so the one will be taken into consideration. I will add one. After that, the next one will be 10. Okay, so 10, because we have to generate till 13 only. So next one is 10. After that, if I try to take the next like lexicographical one, that will be 100. But as 100 is greater than our 13, so I won't consider it. I will come back in my recursion. So the next call will be made for double one. Okay, so I will take double one, and after that I will try to make a call for 110. But as that will be out of range, so I won't do that. So after that there will be 1 2, there will be 1 3. Okay, so okay, so if you take the next one, that will be 1 4, but 1 4 is out of our range, so we won't consider it. So what will be the next number? Next number will be 2. Okay, so for 2 I will also go ahead and make some recursive calls like 20, but as 20 is out of our range, so I won't consider it. Okay, so that's how I'll be generating the numbers. So now let's just go through the code and see like how I'm doing these things in the code, because like the logically we are just doing this only. We will go to every number from 1 to 9, 1 2 3 4 5 6 7 8 9. So for each of the number I will make a recursive call to generate all the numbers. Okay, so like this I will be making recursive calls and I'll generate the numbers. So in the code what I have done is, so what I'm doing is I'm just creating a list. So in this list, I'm trying to iterate over all the numbers from 1 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'll be going from 1 to 9. Okay, so on all of the numbers, I'm making recursive calls. Okay, and if at any moment I found that the current number is greater than my required like limit, so the limit is given as n. So if it is greater than n, I'll just return out of the loop. If it is not greater, then it's part of my range only, so I will add. And after adding, what I'll do is, so what I have done over here is, so suppose if you were at 1, I multiply it by 10, and I add, so basically I multiply it with the numbers 10. Okay, so what multiplying by 10 gives us? It gives us the next like number, and after that I'm just adding a 0 or 1 or 2 or 3 in it. Okay, so that will give us the next numbers. Okay, so as of now, in the beginning, you can see I'll be adding a 0 over here, so this will give me 10. If we take just this test case only, so for this test case, this will be giving me a 10 plus 0. Okay, so I'll be making a recursive call. Then I will again come back over here. So is 10 greater than 13 or not? So I will be adding it into my list. Okay, so in my list I'll add, and once that is done, I will again make a call from 10 to 100. Okay, so how that will happen? As currently, then my start would be 10, so 10 will be multiplied by 10, so this will give me 100. Okay, so on that level I will traverse and then I'll add. So that's just how recursively I will be keep on adding the elements till the time they are less than. Okay, and if they are greater than my limit, I will just break out of the recursion, and I will not expand that branch anymore. Okay, so yeah, that's what it. uh, I hope I was able to make you understand the logic behind this problem and you were able to understand. So, one thing which is remaining is what's the time complexity and what's the space complexity. So, the time complexity for this will be O of n. Why? Because I'm iterating over every number once only. Okay, so I'm going to 10 at only one time. I'm going to 11 only one time, 10 one time. So on every number, I'm just going from at one time maximum. Okay, and at max, I'll be just going to the n numbers only. From 1 to n, I'll be going to each of the numbers one time. And what will be my space complexity? So space complexity is, as such, we don't have used any other space directly. This list we don't need to consider because that's just the output expectation. So we won't be considering that. Apart from that, this recursive call will take some space. And how much space will it be? The length of the depth of the stack. Okay, so how much will be the depth of the recursive stack? Okay, so that would be at max the number of digits in my number. So okay, so in the constraint the number is given as 5 into 10 to the power 4. Okay, 5 into 10 to the power 4. So 10 to the power 4 are at max 5 digits. Okay, so if I go to each digit, if I go to 10, if I go to 100, if I go to 1000, if I go to 10,000. Okay, so at max, the length can be of 5. Okay, so the recursive depth will be 5 only. It won't be greater than 5 at any time because the n is given as 5 into 10 to the power 4. Okay, so the space complexity, if you want to know exact, that will be log of n. Okay, log of n will be the space complexity. So, but also the at max we are using only like 5 recursive depth. So you can also like sometimes you can say it like it is of one and only because at max it is like 5 depth only. So yeah, that's about it. So thank you.